You're here because you want to cut through the noise and, really understand complex stuff without wading through tons of research.
Right.
So consider this your fast track. Today, we're diving deep into something called dimensional comparison theory, or DCT.
Yeah, DCT. It was formally laid out by Muller and Marsh about 10 years back now, looking at how we sort of internally compare our different skills.
Internally compare, like how good I think I am at writing versus, say, public speaking?
Exactly that. Those moments where you feel maybe really sharp in one area, but less confident in another, even if you're generally capable. DCT gives us a language for that.
Okay. We all kind of do that, have that internal scorecard. Good at this, maybe not so hot at that. But what kicks this theory off? What was the big question?
Well, this is where it gets really interesting. Marsh, way back in '86, noticed something odd.
Uh-huh.
He found that students good at math often tend to be good at verbal stuff too, right? Their actual grades, their performance, it's positively correlated.
Makes sense. Smart kids are often smart across the board.
Generally, yeah. But here's the twist. How they felt about their math ability versus their verbal ability. Almost zero correlation. Like, their confidence in one area have nothing to do with their confidence in the other.
Wait, so good grades in both, but confidence levels all over the place.
Pretty much. That's the paradox DCT was built to explain. Why the disconnect between actual skill and self-perceived skill across domains.
That is a puzzle. How does DCT explain it then?
The key concept is something called the contrast effect.
Contrast effect, okay.
When we do that internal comparison, math versus verbal, for instance, we tend to sort of exaggerate the difference. If we see ourselves as stronger in math, we might mentally boost that math self-concept.
Uh-huh.
And at the same time, we kind of push down our verbal self-concept, relatively speaking. It's this internal seesaw.
So because I'm good at X, I must be less good at Y, even if objectively I'm decent at both.
That's the core idea of the contrast effect in this context. It's that comparison itself that drives the self-perceptions apart.
Okay, got it. So our mission today is to really unpack this DCT, right? Look at its assumptions, how it's grown over the last decade, and why it matters beyond just, like, school grades.
Exactly. We'll draw on various sources, including a key review from Educational Psychology Review to trace its journey.
All right, let's dive in. The theory asks these core questions. Why do we make these comparisons? With what domains and with what effect? Let's start with the why. What's the motivation?
Good starting point. So like other comparison theories, social, temporal, DCT looks for the drivers. Early on, before DCT was even fully formed in 2013, research suggested motivations like boosting self-worth or improving mood.
Like, if I feel bad about my coding skills, I remind myself I'm a great cook.
Kind of, yeah. Focusing on a strength to offset a perceived weakness.
Wow.
But later work, especially experiments by Wolf and others, really highlighted another big motivator, self-differentiation.
Self-differentiation, like figuring out who I am.
Exactly. We seem to have this need to understand our unique profile. Where do I excel? Where am I relatively weaker? These dimensional comparisons help us define ourselves, our cognitive or skill-based identity. It's about self-knowledge, not just feeling good.
That makes a lot of sense. Knowing your relative strengths helps you decide where to, put your effort.
Absolutely. And there was an early study, Muller and Kohler again, that showed something fascinating. Getting feedback, say, a good score in math, then a less good score in verbal. That relatively weaker second score could actually make people feel more satisfied with their first score. The contrast sharpened the feeling about the first success.
Wow, okay. So the why is partly mood, partly self-worth, but maybe fundamentally about defining ourselves. Now, with what do we compare? What are the comparison domains?
Well, initially, as DCT grew from the older IE model, the big focus was academic. Math and verbal were the classic pair.
Right, the ones Marsh studied.
Exactly. But then researchers started using diary studies, asking people about comparisons they made day to day.
What do they find?
People compare all sorts of things. How good their relationship is with their friends compared to, say, their family. Academic versus social life. It's much broader than just school subjects.
So it's a general human tendency, not just academic.
Seems like it. Those diary studies also found something called upward dimensional comparisons were more common when people felt down.
Upward. Comparing a weaker area to a stronger one. That seems like it would make you feel worse.
You'd think so, but perhaps it's about focusing on the achievable high point, or maybe just highlighting the difference, as you said earlier. Anyway, beyond the broad life domains, research did expand the academic focus, too.
Beyond math and verbal.
Oh, yeah. Science came into the picture, physics versus a second language, History versus languages, even sports.
Okay, so lots of different pairings. Did they always find that contrast effect?
Not always. This
Yeah.
is where it gets more nuanced. They found assimilation effects.
Assimilation. So
Pretty much. When subjects were perceived as similar, like math and physics, or maybe two sciences, sometimes high achievement or self-concept in one would positively predict self-concept in the other. Or at least the negative effect was much weaker.
so if I think skills are related, doing well in one boosts my feeling about the other.
That seems to be the pattern. How similar we think the domains are is crucial. It determines whether we get that contrast effect or more of an assimilation effect.
Okay, that's a really important distinction. So why and with what covered? Now, the big one, with what effect? What are the consequences of making these comparisons?
Right. The primary focus historically was academic self-concept. And as we mentioned, those contrast effects, higher math achievement predicting lower verbal self-concept, and vice versa, were strongest when students actually believed math and verbal skills were negatively correlated.
Like if you buy into the math person versus word person idea.
Exactly. If you hold that implicit theory, the contrast effect gets amplified. It becomes a self-fulfilling prophecy in terms of self-concept.
And this holds up over time.
Longitudinal studies, looking at students over months or years, generally supported this. Within what they called the reciprocal IE model, they found these negative cross-domain effects persisted. Achievement in one area could negatively impact self-concept in the other area later on.
Okay, so self-concept is key. What about other effects? You mentioned mood earlier.
Yes, those diary studies showed mood effects, upward comparisons leading to more positive feelings, downward to more negative, which, as you noted, seems a bit different from the self-concept contrast, highlighting the complexity.
What about how others see us? Do teachers see students this way?
That's really interesting. Generally, no. Teachers tend not to show these contrast effects when rating students. They seem to rely more on social comparison. How does this student do in math compared to other students in math?
Not compared to their own verbal skills.
Right. They seem less influenced by the student's internal dimensional comparison. Peers, interestingly, sometimes show positive assimilation effects in ratings, but parents.
Parents are different.
Sometimes, yes. Some studies find parents do show contrast effects, especially when judging their child's self-concept in different areas. They might pick up on that internal comparison the child is making.
Fascinating. Okay, so that gives us a good grounding in the original ideas. DCT itself is now about a decade old. How has the theory itself changed or developed since 2013?
There have been some really important theoretical refinements. A big one is the generalized IE model, or GIE model.
Generalized, so broader than the original.
Exactly. The original IE was mainly math-verbal self-concept. The GIE model says, look, these dimensional comparisons happen between lots of different subjects, not just math and verbal. And the predictors aren't just achievement grades. They could be things like how supported you feel by the teacher in different subjects.
Okay, so comparing teacher support in math versus English.
Potentially, yes. Or comparing your interest in different subjects. And crucially, the outcomes aren't just self-concept. They could be motivation, choices, emotions, a much wider range. And the GIE model explicitly includes those assimilation effects for similar subjects alongside contrast effects for dissimilar ones.
So it's a much more flexible and comprehensive framework for these comparisons across many facets of life.
That's the goal. It moves beyond the constraints of the original model.
What else? Any other big theoretical steps?
Another key one is the 2IE model.
2IE, what's the second I?
It stands for two types of internal comparison. The original focused on dimensional comparisons, X versus Y. The 2IE model adds temporal comparisons into the mix.
Temporal, like comparing myself now to myself in the past.
Exactly. So it considers how my math achievement affects my math self-concept, that's temporal, and how my math achievement affects my verbal self-concept, that's dimensional, and vice versa. It models both simultaneously.
Okay, so it adds that layer of self-improvement or decline over time. What do they find?
Interestingly, even when accounting for the positive effects of seeing your own progress over time, those negative dimensional comparison effects, math achievement hurting verbal self-concept, still typically show up, usually moderately strong.
So even if I know I'm getting better at math, comparing it to verbal still puts a bit of a damper on my verbal self-image.
That's what the 2IE study suggests, yes. The dimensional comparison has its own distinct effect.
Okay. Any other major theoretical links?
Yes, a really important connection has been made with situated expectancy value theory, or SEV.
SCVT, that's Eccles and Wigfield's work on motivation, right? Like, can I do this and do I want to do this?
Precisely. Those are the core questions SEVT focuses on. DCT adds a comparative layer to them.
How so?
It shifts the question slightly. It's not just can I do math, but how well can I do math compared to how well I can do verbal, and not just do I find science interesting, but do I find science more interesting than history?
It introduces that relative judgment into the expectancy and value calculations.
Exactly. So now all the different parts of SEVI, the influences on our expectancies and values, the components of value like intrinsic interest or utility, the consequences like choice and persistence, they can all be looked at through this dimensional comparison lens.
Does it suggest certain parts of CEVIT are more affected?
Well, there's speculation and growing evidence that constructs like perceived costs might be particularly sensitive.
Costs like the effort involved.
Or the opportunities missed. Like if I spend time studying math, which I feel weaker in, I lose time for English, where I feel strong. That perceived cost might feel much higher because of the dimensional contrast effect on your self-concept and value.
That makes total sense. Okay, so the theory has definitely expanded. What about the empirical findings over the last 10 years?
Yeah.
What has the data shown?
Yeah, lots of research. Let's start back with the classic IE model. Remember that paradox?
Math verbal achievement correlated, but self-concept's not.
Right. Well, a big meta-analysis in 2020, pooling data from tons of studies, basically confirmed the original findings quite strongly. That near-zero correlation between math and verbal self-concepts holds up. And the negative cross paths, high math achievement predicting lower verbal self-concept, high verbal predicting lower math self-concept, are consistently found.
So the core phenomenon is really robust.
It's extremely. They even managed to link the IE model with the big fish little pond effect using international PISA data, showing how both social and dimensional comparisons shape self-concept.
Interesting. Any debate or nuance there?
Well, one point of discussion is the net effect. The original 2013 paper maybe leaned toward seeing dimensional comparison as potentially positive overall, but some later work suggested the positive effects from comparing down to a weaker subject might cancel out the negative effects of comparing up to a stronger one, resulting in a negligible net effect on overall self-worth, even if it changes the pattern of self-concepts.
So it rearranges how you feel about specific areas, but maybe not your overall sense of competence.
That's one interpretation being debated. Now, moving beyond math and verbal.
Right. The GIE model suggested comparisons happen everywhere.
And the research followed. Studies have looked at foreign languages, history, PE, music, you name it, and a general pattern emerged, often discussed in terms of a math-verbal continuum, or far versus near comparisons.
Far versus near.
Yeah. Comparisons between subjects seen as very different or far apart, like the classic math verbal, tend to show those strong contrast effects.
Okay.
But comparisons between subjects seen as more similar or near, like maybe first language and second language, or math and physics often show much weaker contrast effects, or sometimes even positive assimilation effects.
So doing well in German might actually make me feel a bit better about my French, maybe.
Could be, yeah. Or at least it's less likely to make you feel worse about your French compared to how doing well in math might make you feel about English. The meta-analysis looked at lots of pairs and confirmed this general trend, though there's some variability, especially within the verbal domain itself. But the big picture is perceived similarity matters hugely.
Got it. Now, the GIE model also said the predictors aren't just achievement. Has research looked at other predictors?
This is actually an area with less research than you might expect, but it's growing. Some interesting studies looked at perceived teacher characteristics.
Like the teacher support example.
Exactly. Things like teacher support or perceived unfairness, or whether the teacher focuses on individual improvement. There's some evidence that perceptions of the teacher in one subject can have these cross-domain contrast effects on motivation or self-concept in another subject.
So loving my history teacher might slightly dampen my enthusiasm for my science class if I feel less supported there.
That's the kind of effect they're investigating. There's also work looking at motivational variables as predictors, like, does my interest in science predict my self-concept in math via a contrast effect? Findings here are a bit mixed, sometimes showing contrast, sometimes assimilation. We probably need more experimental work to really nail down those causal links.
Okay, so achievement is still the main predictor study, but others are emerging. What about the outcomes? Beyond self-concept, what else do these comparisons affect?
This is where research has really blossomed. A major area is subjective task values, or STVs.
The do I want to do this
Yeah,
part of CEVIPA.
exactly. Components like intrinsic value, enjoyment, utility value, usefulness, attainment value, importance, and costs. Studies consistently find dimensional comparison effects here.
Contrast effects.
Often, yes.
Yeah.
Higher achievement or self-concept in math might predict lower intrinsic value for verbal tasks, for example. These contrast effects seem particularly strong for intrinsic value and for perceived costs, maybe less so for utility value.
So feeling better at math makes English seem less fun and more costly in terms of effort or lost time.
That's the pattern often observed. And self-concept frequently acts as a mediator. The achievement affects self-concept, which then affects the task value component.
Mm-hmm.
There's also cool person-centered work looking at profiles like students high in both math and verbal interest versus those high in one and low in the other, and how these profiles relate to dimensional comparisons and later choices. It seems that these comparisons really shape our motivational landscape. Though, interestingly, the effects seem less pronounced in younger primary school kids.
Maybe they haven't internalized those comparisons as much yet.
Possibly. Developmentally, these things often become stronger in adolescence. Other outcomes studied include affective variables.
Emotions.
Yeah, like satisfaction with test performance, general enjoyment of a subject, even test anxiety. There's evidence for contrast effects here, too.
Yeah.
Doing well in subject A might increase anxiety about subject B, maybe because the standard feels higher now.
Right, that makes sense. What about real-world consequences?
Choice is a big one. Course selection in high school, university major choice, career aspirations. Self-concepts and values, which we've seen are shaped by dimensional comparisons, are major predictors of these choices. If you consistently feel better and find more value in STEM subjects compared to humanities, you're more likely to choose a STEM path.
So these internal comparisons echo through major life decisions.
They seem to. And even perceptions of the learning environment itself might be affected, though research here is more limited. Feeling strong in one class might make you perceive the teaching quality or your relationship with the teacher in a weaker subject slightly more negatively.
Wow, the effects are quite wide-ranging. Okay, what makes these effects stronger or weaker? What are the moderators?
Good question. We can split them into substantive moderators, things about the person or the context, and methodological ones.
Let's start with substantive.
A huge one, as we touched on, is perceived subject similarity. The more similar you think two subjects are, the weaker the contrast effect and the more likely an assimilation effect. Related to this are interdependence beliefs. Do you think being good at math helps you be good at physics? If yes, you'll likely see assimilation. If you think they're totally separate, maybe contrast.
So our own beliefs about how skills relate are critical.
Absolutely. Another major one is age or grade level. As mentioned, meta-analyses show these dimensional comparison effects, especially the contrast between math and verbal self-concepts, tend to get stronger as kids get older, moving into secondary school and beyond.
So we learn to differentiate more sharply over time.
It appears so. The correlation between math and verbal self-concepts actually decreases with age, suggesting more pronounced dimensional comparison.
Okay. And methodological moderators, do they matter much?
They can have some influence. Things like sample size, publication year, newer studies might use different methods, and exactly how achievement is measured. Standardized tests versus grades can sometimes slightly alter the strength of the observed effects, according to meta-analyses. But the substantive ones, like perceived similarity and age, seem to be the bigger drivers.
Makes sense. Now, what about significant others? We talked about teachers mostly not showing contrast, but parents sometimes do. Can you elaborate?
Yeah, the findings for teachers are pretty consistent. They seem to rely mainly on social comparison, student versus peers, and often overlook dimensional comparisons in their ratings. Some studies even find teachers show slight assimilation effects.
Okay.
Parents, however, seem more prone to contrast effects, especially when judging their child's self-concept or maybe even their perceived talent in different areas. They might internalize the child's own comparisons more.
So they might rate the child's math ability lower if they see them as a verbal kid.
Not necessarily their ability rating, but perhaps their rating of the child's confidence or interest in math might show that contrast. It's subtle. And peer ratings have sometimes shown positive effects, assimilation. And that twin study was fascinating.
Right. One twin's achievement affecting the other's self-concept in a different domain.
Yeah, showing these cross-domain influences can even happen between closely related individuals.
Okay. And does this apply beyond K-12? What about university students or even professionals?
Definitely. Studies have found dimensional comparison effects among university students in psychology, maybe comparing stats versus clinical skills in teacher education programs, comparing different subject didactics, and even in sports science students comparing different disciplines.
So it continues into higher education.
It does, although interestingly, one study on university faculty members found positive assimilation between their self-concepts for research and teaching.
Oh, why assimilation there?
Perhaps because, at that level, research and teaching are seen as highly interconnected and mutually supportive activities for a successful academic career rather than competing domains. Again, perceived similarity or interdependence seems key.
That's a great example. And are these ideas spreading outside education and psychology?
Increasingly so, yes. This is a really exciting development. DCT is popping up in clinical and health psychology.
How so?
Researchers like Nazar Marina are using it to understand how people make comparisons after trauma or in relation to body image and appearance concerns and how that impacts well-being. There's also work on health risk perception, comparing your risk for one disease versus another.
Comparing health risks, like my cholesterol is okay compared to my blood pressure.
Something like that, yes.
Huh.
Or comparing your own health behaviors. I exercise more than I eat healthily. These internal comparisons seem relevant for understanding health choices and anxieties. Interestingly, the mood effects found in some clinical contexts seem different from the early diary studies in education, which needs more exploration.
And beyond health.
Yep. Applications are emerging in economics, maybe related to how people evaluate job offers or compensation packages by comparing different aspects. In personality psychology, looking at how we compare different facets of our own personality, like agency versus communion. And even in sports and activities, comparing engagement or skill in different leisure pursuits.
Wow. So a theory born from math and verbal scores is proving useful across the board.
It really speaks to the fundamental nature of comparative judgment and how we evaluate ourselves and the world.
Okay, one last area before we wrap up. Methodology. How are people studying this? Has that evolved?
It has. For a long time, the dominant approach was correlational, using statistical models like the IE or GIE model on survey data to infer dimensional comparisons from the patterns of relationship.
Which is powerful, but doesn't prove causation.
Exactly. So while those sophisticated statistical methods are still crucial and getting more advanced, there's been a push for other approaches.
Like what?
Well, more use of person-centered approaches, like latent profile analysis. Instead of looking at average effects, this tries to identify subgroups of individuals with different patterns of abilities, self-concepts, or values, and see how those profiles predict outcomes.
So finding clusters like the high math, low verbal type versus the high both type.
Precisely. And seeing how those distinct profiles relate to choices or motivation. And critically, there's been an increase in experimental and intervention studies.
Actually manipulating things.
Yes, trying to directly induce dimensional comparisons in a lab setting, perhaps by giving specific feedback or seeing how framing a task influences self-concept reports. Or intervention studies that try to boost motivation in one area and see if it has contrast or assimilation effects on another.
That sounds crucial for understanding the mechanisms.
Absolutely. While still less common than correlational work, these experimental and intervention designs are vital for testing causality and exploring potential applications, like how to maybe mitigate negative contrast effects.
Okay, this has been incredibly thorough. So pulling it all together after this decade-long journey with DCT, what are the really key takeaways?
I think the biggest one is just how fundamental this process of internal comparison is. We don't just evaluate ourselves in a vacuum, we constantly weigh our different abilities and characteristics against each other. And DCT gives us a really valuable framework for understanding how that happens and what the consequences are for our self-perception, our motivation, our choices.
Yeah, and for me, that core aha moment is still that weird disconnect between actual skill and self-belief in different areas, like math and verbal. The contrast effect really explains something that feels counterintuitive otherwise. It's not just how good you are, it's how good you feel you are relative to your other skills.
Exactly. And it prompts that question for everyone listening, right? Where in your own life, work, hobbies, relationships might you be doing this? Are you perhaps selling yourself short in one area because you perceive yourself as particularly strong in another? It's worth reflecting on.
Definitely. Which leads to a final thought, maybe. Given that we see these dimensional comparisons playing out everywhere now, education, health, economics, personality, what does that mean for us? If we get better at understanding these internal, often unconscious comparisons, could that help us make, wiser choices? Or maybe cultivate a more balanced, accurate view of who we are?
That's the million-dollar question, isn't it? Can awareness of this process help us counteract its potential biases? Can we learn to appreciate our strengths without necessarily devaluing other areas? It's a fascinating challenge, both personally and for future research.
Food for thought indeed.
Oh,
If you want to get into the nitty-gritty, we absolutely recommend checking out that review article we base much of this on. It's got tons more detail, plus pointers to where the research might go, and look for the supplemental table they mentioned. It lists a lot of the specific studies.
yeah, definitely worth a look for those who want the full picture.
Well, thank you so much for guiding us through that. It's been a fantastic deep dive.
My pleasure. Always fascinating to explore how the mind works. Until next time.